Welcome to week 2 in statistics at Blue Mountain Community College. This week, we're going to do one quantitative variable stuff. So shape and center, we'll take a look at in a moment briefly. And there's a bunch more to look at in the book and in the videos and in the assignments. And we'll look at measures of spread and then a quantitative and categorical variable together with box plots. So that's the goal for this week. Moving on from the introductory part of what is statistics and data, categorical variable on its own. Now we're into a quantitative variable. So I am going to show you some things that are useful tools for exploring a quantitative variable. I'm going to head over to the useful websites page on the course homepage. And in there, I have some links that are important. The textbook comes with data sets, and you can get to them here in the description here. I also have them in Google Drive, so that's helpful if you're a Google user, because you can then just make a copy as a Google Sheet with any data set that you need from the book or stuff I recommend. StatKey is the app that goes with the book, and STApplet is another good tool for playing with data. So now I'm just going to give a quick overview of this week's topics by looking at some data from the book. So first, I'm going to head over to StatKey. Let's blow this up a little bit. And I'm looking at one quantitative variable. And there'll be problems in the book that reference this, and sometimes I'll send you here to reference something. And I'm going to take a look at some of the cars data. So we have cars braking distance, we have cars city mile per gallon, we have cars highway mile per gallon. So I'm going to start off with the braking distance. When I first grab a data set for one quantitative variable, I get what's called a dot plot. What does the data here actually look like? Well, if we go to the edit or show data section, we can see that we have a model and then we have the braking. So question, what does that really mean? Well, you got to do some research to figure that out. So if I go back to useful websites, there's the data set descriptions. So then in order to really understand what that data is, I need a description of it. So here looks a little weird at the top, but it's okay. Otherwise, I'm looking for the cars data. So I have the cars 2020 there. And oops, I missed it by a page or so. There we go. So information about new car models from 2020. So when I'm looking at, say, the data set here, that means I have something about a 2020 Integra or MDX or A3, and I have braking distance related. I'm assuming it's braking distance. That's why I'm looking in here. So then if I scroll through here looking for braking, I can see, yeah, it's the distance to stop from 60 miles per hour on dry pavement. They also mentioned up there the city MPG and the highway MPG. So again, miles per gallon, uh, and that looks like that data came from the EPA. It's often a good idea to look at further detail. So the data set for 110 new car models in 2020 based on information from Consumer Reports, right? And then they have further, where's the source data come from? So, and anyway, whenever you look at a data set, you really need to know what is the sample here, what do we think the population is, and then what do the variables mean? And in addition to making a dot plot with the data, again, because looking at this series of numbers is not really meaningful to me. So the dot plot shows that most cars had a braking distance of 60 miles per hour between 125 and 140 feet, that there were a few that stopped a lot quicker and a few that took longer to stop. Histogram is a nice tool. We'll make a lot of histograms in this class, and StatKey makes pretty quick histograms. If you point at a column, the left side will show the boundaries of the column you're pointing to, and you can always edit. So I could set limits here. it set the minimum to 111, which is the minimum braking distance in the data set, and the maximum to 150. So I can tweak that. I'm going to go a little lower, 110. And then here I have control over the number of buckets, the number of columns that we separate data into. So we're going 40. If I have 10 buckets, that means they're spaced by 4. So it would go 110, 114, 118, 122, and so on, up to 150. Let's give it a try. All right. Notice it doesn't quite match the numbers down here, which are jumping by 5. So we could adjust again to make that happen. We just have to do a little arithmetic. If I'm going from 110 to 150, that's a distance of 40. And I want to break that into chunks of 5. 5 goes into 48 times, then I would have 8 columns. So some programs like Excel allow you to adjust either the number of buckets or columns or the width. Google Sheets allows you to adjust the width, which I think is a pretty easy way to do it. Okay, so now I have my columns line up with the numbers that StatKey had picked here on the bottom. StatKey is a nice place to go play around with histograms. There is no best histograms, but there are certainly bad ones. A histogram is one of the few graphs you can make out of a single categorical variable. You can make a histogram, you can make a dot plot, and you can make a box plot, and that's about all you can do meaningfully with a single quantitative variable. And again, I can adjust to see what different ones look like. All right. So again, quick way to get that. If you want to do something similar in a spreadsheet, so here I'm using Google Sheets, then best thing to do is don't edit the original data set. If you want to play around with one of the columns or multiple columns, copy them into another tab. So here I selected the breaking tab and I copied it, put it over here, and then I asked Google Sheets to make a histogram for me. So I'm just going to repeat that. So with the data selected, sometimes you can select the whole column. Other times you should find out where the bottom is and then select all the data from the bottom up and then insert a chart. Usually the spreadsheet guesses at a good chart to make, and it will guess at what the column division should be, and they're usually not very nice numbers. So we are going to redo that to have nice numbers. We are missing a reasonable title at the top. Breaking at the bottom is meaningless. Breaking what? What does that mean? Right? So we need to fix this. And what do these numbers over here mean? 40, 30, 20, 10, so on. So customize is the thing we have to do next. And the first thing we should do is pick a better width for those buckets. So here the width looks like it's about what, 5 to 9.5, so about 4.5. So a better width might be 5. And if you don't see the number you want in the list that Google gives us, then you can pick any number you want. So if you really wanted the width to be 7.5, you could choose the width to be 7.5. You can pick any number you want. There is no best histogram, but there are bad ones. And that seems okay. 105, 110, 115, 120. That's not bad. Usual rules are between 5 and 20 columns, have nice titles, and have nice numbers on the horizontal and vertical axis. Next, we need to fix the titles. So just jumping on over here to the titles, histogram of breaking. Again, that's meaningless. So this would be breaking distance. Oops. For 2020 automobiles. All right, so I have to read the data set description in order to describe it. I think I'm going to add a subtitle to this. So this would be the stopping distance from 60 miles per hour, dry pavement. Okay. And then the braking distance was in feet, so I should label that down here. Braking distance in feet. And then what are the numbers on the side? Well, if I look at the 125 to 130, there were 20, almost 30 automobiles models that year that had a braking distance between 125 and 130. It's just counting how many cars had braking distances within those two boundaries. So this is just counting the number of cars. We could call it frequency. Technically, that's what it is, but that's not really a user-friendly description. So for the vertical, instead of calling it frequency, I would say a better title would be number of cars. Okay, cool. So now I have a good looking histogram. I'm going to move that over because I'm going to add some more things to this as we go. This, we usually like to describe the shape of a distribution. In this distribution right here, the shape is skewed left because I see a tail to the distribution here, and the tail describes the skew. So this is skewed left. Another data set we could take a look at. Let's go back to that survey I had you do about BMCC students in my classes. And if I look at the, oops, not that one, I want the data. Oh, I thought I had a link to the data here. Where did I put it? Well, I need to put a link to it in there. Okay. Just a moment. Okay, link added. So now on the data collection assignment page, there's a link to check out the data. I also put it in the useful websites page. When you make a survey in Google, a form, uh, in your edit mode, you can also view responses. And whenever possible, Google will try to make a chart out of the responses. And sometimes it's meaningful, and sometimes it's not. Here, I'm getting a histogram of the ages, a pie chart of the gender options. The hair color was too varied because people could type anything they want, so Google wasn't sure what to make of that. Eye color, not bad. That needs some cleaning up. Height apparently was variable enough that Google had a hard time making a chart with that. So notice sometimes it made charts, sometimes it didn't. Usual hours of sleep, it made a chart for. So I just want to explore a couple of these next. All right, so to do that, I'm going to look at the data in Sheets, and I am going to grab one of the columns. Let's see, I already grabbed sleep here. So I'm just going to review how I make a chart like this in Google. First step is to select the data you want to make a chart with. When you have a data frame like this, you don't want to edit the original data frame. So what you would do then, if you want to play around with statistics on any variable or variables, you copy them to another tab. So I copied that and I brought it into this tab here, and I labeled the tab sleep. So to make this tab, I would need to select all of the data. And before I do that, I'm just going to scroll down to the bottom of the data set, and there's some blanks. Okay, so the data ends here around row 611, and there's some blanks in between. I can see people occasionally enter decimal numbers for the average amount of sleep. So from the bottom of the list to get to the top, if I hold Control Shift up arrow, that will highlight and take me to the top. It'll pause at every blank cell, and eventually I get to the top. So depending on your spreadsheet tool, sometimes you can select the whole column. Sometimes you have to select just the numbers you want to make the chart out of. Excel is a little pickier than Google, I find. Once the data is selected, then insert chart. And often the spreadsheet will make a pretty good guess as to the kind of chart you want. So here it guessed at histogram. There's pretty much only 3 meaningful charts you can make from a single quantitative variable like I have here. That's a histogram, a dot plot, or a box plot. If the computer said, hey, let's make a line graph, meaningless. It's just a bunch of noise. If the computer suggested making a pie chart, meaningless, bunch of noise. And if the computer selected making a scatter plot, again, it's meaningless. It's a bunch of noise. Single quantitative variable, histogram is the most powerful tool, then a box plot, and sometimes a dot plot. So I'm going to switch this back to histogram, the recommended chart. Again, most programs like Google and Excel and StatKey don't do the best job of making a histogram at the first try. Rules about histograms are between 5 and 20 columns. So this has too many columns, so I'm going to adjust. It's jumping by about 0.4 or less each time, and you should jump consistently. So I'm going to, in the histogram customize setting, I'm going to change from auto to 1. And that's pretty good. If I switch to, say, 0.5, I can see that people did enter some fractional hours for sleep time, but 1 seems pretty good. And again, there is no best histograms, but there are certainly bad ones. So the first one I got with auto wasn't very good. There are too many columns. The numbers at the bottom aren't nice. It's hard to look at. The title at the top is not all that meaningful. The label for the bottom axis is also not meaningful. Usual hours of sleep. Okay, no, that's okay. I take it back. But the title at the top's a little bit lame. It needs some work. And there's no explanation about what the numbers here mean. Generally, a histogram, we're counting how many individuals are in each category. We could call it count, we could call it frequency, but the best is number of whatever you're counting. So here I'm going to adjust some titles. Stating it's a histogram is not useful. Usual hours of sleep in a night for BMCC statistics students. That's pretty much what this is. And then we need a vertical axis, which in this case is just going to be number of people. Number of students would be okay too. Yeah, now it's a pretty good graph, except again for those numbers there. And again, there is no best one. And the one above, I chose to jump by 1 each time. So maybe this one, to emphasize those half hours people had typed in, I could go 0.5 for the jump. A little cleaner than the other one. So again, what we want to do is have some nice numbers along the horizontal axis and an explanation of what the numbers on the horizontal axis mean, what the numbers on the vertical axis mean, and then a good title. And sometimes you need a subtitle. What I noticed about this one compared to the the cars one was definitely skewed left because the tail is to the left. This one does not really have an obvious tail. There's a little tail on the right. There's a little tail on the left. This is more symmetric and bell-shaped. And again, that's one of the descriptions of histograms gone over in the book. So you can have skewed right, you can have skewed left, you can have symmetric, you can have bell-shaped, could be uniform, which means all the columns are the same height roughly. There's a ton of other options. And this one right here, I looked at the ages. There was one typo. Somebody entered the age of 2 accidentally or on purpose. So let's label this ages 2026. And here I can see there's a tail to the right. So this one would be skewed to the right. And I want to emphasize something about skewed right and skewed left by throwing in some summary statistics. When you use StatKey, it gives you summary statistics also. So here I have that car's braking distance. What's this one up here? This is another version of that braking distance I did in Google. So let's make these guys match. And it looks like they're not quite the same data set. Let's check by throwing in summary statistics here. Yes, thank you. So usual summary statistics we want is we want to know what the sample size is. So that would be a count. Let's blow this up a little. And then I'm going to go just for some basic ones right now. I want the minimum, I want the maximum, I want the mean, and I want the median. And commands start with an equal sign. If I start typing count, I'll get an option, count numerical values in a data set. So if I select that and then select the whole column, close the parentheses, it'll tell me how many numbers there are in that column. Minimum equals start typing, and it says, hey, how about the minimum value? Sure. The min A version counts text as zeros, which can throw things off. So I'm not going to use that one. And again, the computer's selecting numbers for me. Sometimes it does a good job. That looks about right. In this case, I know I can also select the whole column. And again, it depends on the function that you're using. Sometimes you can select the whole column. Other times you need to select just the data. Max, data. Mean is average. And we want the one that's just called average. So select it and then select your data. And I'm going to get the same answer if I select the whole column or if I select just the cells that have numbers in them. So just demonstrate that. Here I selected the whole column. You can see it's A colon A. Alternatively, if I do equals average, again, make sure you select the right version. There's a bunch of different average functions. We want the one that's just called average. And I'm just going to go with its suggestion. Notice I get the same answer. And just takes experience to get used to when you can select the whole column and when you can't. Median is median. And select the data, sure. Okay, so I have a mean and median. They're pretty close to each other for the breaking distance. If we look over at StatKey, it says the median is 131 and the mean is 131.93. So again, I must have slightly, oh, this is the fourth edition of the data. Back here, I'm playing with the third edition of the data. So they update the data occasionally. Do they have the third edition here? They do. So if I go to that one, that should match what I have in my spreadsheet. There we go, the 131.818. All right, so let's look at the average person again, and I want to go over to the sleep one, and I'm going to do the same kind of stuff here. Now, one cool thing is if you have functions that do calculations based on column A, like I do in the car sheet, I can just copy all of this stuff here. Oop, wrong button. Control C to copy. And then in this other spreadsheet, if I paste it in the same spot, so starting in B1, then it will use those same formulas to recalculate. So copy and paste the count command for column A. This time it says there's 606 numbers in the list, that the min is 3, the max is 12, the mean is 6.94, blah, blah, blah. The median is exactly 7. And rounding rule, one more decimal than the data. So the data occasionally has a tenth. So then I would round this to the nearest hundredth, unless you're asked to do something else. All right. And let's check out the ages. I already have some summary statistics there. I'll talk about the standard and deviation and the coefficient of variation in a minute. And then let's see, this one here is missing the count. So let's just move this stuff over a little. And that would be just equal count. You don't want to count yourself. You don't want to look at the row number in case there's blanks. And I'm going to do the whole column. Okay, so I can see that there are 602 values when I'm looking at the ages. And when I'm looking at the sleep, there's 606 values altogether in my spreadsheet. I think 610 people have completed the survey so far. All right, two more things. I'll let you go do some other stuff. Let's look at my notes. I want to see ages. Yeah, this one has a skew right. I want to take a look at this. All right, so what I want to do is I want to mark off on here some information. So on the histogram, I would like to locate the mean, 25.4. So the mean is about right here. Oh, and my pen is being difficult. Oh, it doesn't want to write it all now. Try it again. How about now? Oh, we're having technical difficulties. All right. Let's try, instead of my magic pen, my mouse. There we go. All right, so that right there is my mean. The mean is usually the symbol X with a bar over the top. And excuse my penmanship, I'm writing with my mouse, so I'm having technical difficulties. My median was 21, which is somewhere over here-ish. And the median, we usually use the symbol lowercase m. That's my best lowercase, m at the moment. Oh, that's not good. Try again, Gare. All right, so notice here that the mean is higher than the median. The reason is there's only a few people whose age is much higher than the majority. Majority of students have an age between 15 and 30, and then there's some what we would call outliers, some unusually high ages in this group. Where when I look at, say, the braking distance data, that one is skewed the other way. So let's bring that to scribble on. That'll work. So here I have a mean of, no, they're both pretty similar, 30.08 or 130, excuse me. So that would be, let's say about here. So that would be my X bar, and sitting just a tiny bit next to it, about right here-ish, that would be my median. So the mean is slightly less than the median. And what will happen in most data sets is that if there is a tail, that's what we call the skew of the data, that tail will drag the mean away from the median toward that tail. Okay. And again, the reason is the median is the biggest number, sorry, the middle number when the data is ordered. And it doesn't matter whether the minimum is 105 or 110 or 115, the median is still going to be in that middle spot. The mean, however, you have to add up all the numbers and divide by how many. So these smaller numbers are in the sum for the numerator for the mean, so they are going to affect the mean, but those farther out numbers on either side are not going to affect the median at all. So we can see if it's skewed left, this has a tail to the left, the mean will usually be to the left of the median. And if we have a skew to the right, oops, wrong way, then we'll find the mean is being pulled toward the tail away from the median. And if it's more symmetric, the mean and median should be pretty close to on top of each other. So for example, if I look back at the sleep data for my students, the mean is about 7 and the median's about 7. So they're almost right on top of each other. And again, somebody might argue that there's a slight skew here to the right, but again, the mean is lower than the median, which indicates a slight left skew to the data. There are calculations for skew. We're not going to go over them in this class. We're just going to observe the graphs. So when we talk about the distribution of data, we're talking about the shape of the histogram. And histograms can have many shapes. The ones we're looking for are symmetric, bell-shaped, which sometimes are the same, but there's other symmetries one could have. And then skewed left and skewed right. So skewed right means there's an obvious tail to the right, and skewed left means there's an obvious tail to the left. All right, last thing for now, and there's a whole bunch more things you're going to play with in the book, is I want to take a look at standard deviation. And I have that calculated up here for this data set. Standard deviation is the average spread from the mean, or at least one measure of that. And again, this is in the book, and my magic pen isn't working at the moment. Let's see, I'm going to pause and see if I can reboot it. Got it. So my definition of standard deviation is a measure of average spread from the mean. So let's just say the mean is exactly 25. If somebody is 20 years old, then they are 5 years below the mean, the average. And that would be their deviation. If somebody is 30 years old, they're 5 years above the mean. So deviation is distance from mean. Standard deviation tries to average that out. The way we do that is we take a measurement, someone's age, we subtract the mean. That gives deviation. Since that could be positive or negative, we square that to get rid of the sign. And then we add up all those squared deviations. So sigma means add stuff up. To do an average, we have to divide by how many. And it turns out instead of dividing by the count is usually called n, it turns out it's better with a sample to divide by n minus 1. Now, this gives me an average of the squares of the deviations. So that would be squared hours, which is weird. So to undo the square, we take the square root after we add all that up and divide by n minus 1. And this is the calculation that's called standard deviation of a sample. We give it the letter S. Easier way to do it is to give your spreadsheet the data and then use the stdev command and highlight your data. Alternatively, you could use the stdev-s command for sample and then give it the data. There's one for populations, but we almost never have a population. Since standard deviation is the average spread from the mean, then we can use that by counting from the mean. So let's say the mean is about 25. So I'm just going to round that to 25. And the standard deviation, I'm going to round that to 9. So that means from 25, if I count 9 to the right, so 25 plus 9 would be 34. So an age of about 34 is plus 1 standard deviation. If I take the 9 away from that 25, 25 minus 9 would be 16. Then an age over here of 16 would be minus 1 standard deviation from the mean. So technically, it's the mean minus 1 standard deviation. And that 34 is the mean plus 1 standard deviation. And you can keep going on either side. If I add another 9 to the right, 34 plus 9 would be 43. So that's going to be about right here. So an age of 43 is plus 2 standard deviations. And again, we can't go any further to the left because we ran out of data, but we can keep going to the right. Every data set's a little different. So 43 plus 9 would be 52. So an age of 52 is the mean plus 3 standard deviations. And usually we abbreviate the plus 1, plus 2, plus 3 by just giving it a number. So instead, I would just call that 1 standard deviation to the right, 2 standard deviations to the right, 3 standard deviations to the right. The mean itself would be 0 standard deviations because I'm at the mean. And that 16 would be 1 standard deviation to the left, or negative 1. When you just count as a standard deviation, 0, 1, 2, 3, those are called z-scores. And there'll be more about z-scores in the book. Okay. So next, we just have to get used to the idea of a distribution of a data, shape of the graph of a histogram, and then how the mean and the median are related, how the standard deviation is related to the mean, and then the next topics coming up are going to be other values that are related to the median, and those are called percentiles. So stay tuned for that. Take care, do good math. I'll be in touch soon. Bye-bye.